Hello everyone and welcome to a new IBM RPG sample video. In this video we're going to talk about the lookup built-in function in RPG. As you all know, lookup is a function that helps us to find elements in an array. It returns the array index of the item that matches with the first argument of the function. And also we have some different lookup functions that we can use depending on what we are looking for in the array. Maybe we need to find an element that is equal to the argument, or maybe we are looking for an element that is less or equal, greater or equal than the argument. We have all these options, but be careful with this because it will only work if your array is declared as a sequenced array, and if the elements inside the array are not correctly sorted, then the result can be unpredictable. We will have an argument, an array to search into, and also a few more parameters to help us find what we need. So let's go. Well, as you all know, I used to make these videos as much practical as possible, so let me write a simple RPG program and I'll show you how lookup works in different examples. So let's start with the most basic example using a simple array of colors. For example, we'll search for a value that exists and then for a value that doesn't exist. So you can see the difference in the return value. So let me start. As always, you know, I'm using code for I. Okay, let me write a few lines of code. We're gonna write a program without the cycle. Okay, let me declare the main procedure. Great. Well, for example, let me declare this field that is going to be an array of 100 positions. Okay, this is going to be an index. And we can declare this this array this way as a list. Apple, let me write banana, and grape, for example. Well, so for example, if I want to look for a fruit that is grape in my array, I can use lookup there, and we will get the index number of the place where this fruit is in my array. Okay, so we can write it into my job log this way. The position is, for example, plus index. Oops. Okay. Well, imagine that we are looking for example, P. Okay. Well, let's see which index we will get then. Okay, let me compile the program. Okay, and now we're gonna run it. Change, we're gonna run this program that is this way. So we can run it this way, run action, call program, and well, we're getting a 6 and a 0, okay, as you can see. Well, why? Well, because grape in this case is the 1, 2, 3, 4, 5, 6 element in my array, so the position is 6, okay, and P is the position is 0 because P is not a fruit. Okay, well, this is the basic usage options for lookup. Okay. Well, let's go a step ahead. Imagine we need to know the position of pitch, but I want to search that element between the positions 4 and 6 of the array. Okay, so for example, we can do something like this. Let me remove this because I don't need it anymore. And we can look for this element between the position 4 and 6. Okay, what will happen then? Well, let me compile it again. Okay, and if I run it, run action, call program, then this is what I'm getting. Position is 6 again. Well, the position is the same. Okay, but we have been looking for grape between these two positions. Okay, if I write here a 1 and a 3, of course it is going to look for this element between the position 1, that is apple, and the 3rd, that is orange, and also it is going to check the second position, that is banana. So this will return a 0. Let's see if it is correct. Run action, call program, and yes, the position is 0. So well, as you see, this option is very cool if we want to search between two different positions. Okay, but if we want to start to look for the element that we are looking for a position without telling the end position, we can set the position this way. Okay, and it will search it from the position number 4 until the end of the array, in this case the element number 100. Okay, well, let's now talk about sequenced arrays. Well, if you really want that lookup runs faster and your programs have a better performance, then you should use sequenced arrays. For that, it is very important to declare them as ascend or descend arrays. Well, also it is very important to use the built-in function sort array before doing a lookup, because if not, the result can be unpredictable. Okay, let me show you an example of this. For example, let me write here ascend. Okay, this way we are making this array a sequenced array. Okay, but we are not going to sort all these elements. If you see apple, banana, orange, pear, peach, grape, this is not sorted. So if we want to look for this element, grape, what we are going to get, well, in this case, let me run it. Well, we are getting a 0. Well, you probably will say, how is that possible? Well, that is because the array is not correctly sorted, as I told you before. Okay, so to solve this, it is important to do this. Always before the lookup. Okay, so in this case, if we run it again, let me run it again, then we are getting this number 97. Maybe this is a surprise for you, but it is not really a surprise. Well, this is because the array is a 100 positions array, and all the first elements, as I have been sorting the array, all the first elements are empty elements, so they are before the apple, banana, orange, pear, etc. So the real position of grape is the 97 position. Okay, so Well, to solve this, what you need is to declare the fruits array as, for example, an auto array. So it will be internally an array of 6 positions, or just declaring it as a 6 positions array. Okay. Well, for example, if we do something like this, automatic array, okay, and we compile it and run it. Well, the position now is the position number 3, okay, because grape is A, B, C, D, E, F, G, okay, is the third element into the array. What else we can do with sequenced arrays? Well, remember what I said before about looking for a value less than, greater than, etc. Well, with sequenced arrays, we can use all these options. For example, let's look for a fruit that is greater than the coconut, for example. Okay, how can we do it? Well, this is very easy. You just have to do something like this. Look at coconut, but not lookup. We are going to use lookup greater than coconut. Okay. Let's see what we're going to get in that case. Run action, call program, and we're getting the number 3. Okay, why is this? Well, because a coconut starts with the letter C, and we have apple, that is the first, banana the second, and the third element is the grape. So what is greater than coconut? Okay, greater than coconut is the grape, that is the third element into my array. Okay, as I told you before, in the same way we can use lookup greater equal, less than, and less equal. Okay, it works in the same way completely. Well, now let's see how we can use lookup to look for an element into an array of data structures. This is an array a little more complicated, so we are gonna try to use it. So let me close this, and let's well, let me remove all this. Let me declare a structure a little more complex, qualified structure. For that, we are going to use this functionality, this extension that I have made. That is, well, this extension is the RPG structure extension. You can download it and use it. It is free, of course. And this way we can declare data structure in a very easy way. So, for example, we are going to declare fruits. That is a qualified structure. That is going to be a structure default because we are going to use a structure of 100 positions. Okay, and we have 2 fields. The first is name, the name of the fruit, with that is a character of length 10 with no initial value. Okay. And also we are going to have I like it. Okay, I like the fruit. That is an indicator. Okay, well, we have without initial value. Well, and we can put this structure here, for example. Okay, as you see, it is automatically written into the source. Okay. Well, this is because of the linter that I have it configured this way. Okay, no problem. Well, let me now declare index as before, and let me copy a few elements from a different screen that I have. Okay. Okay, well, this is because I have brought it, oops, I like it this way. Okay, well, we have a few fruits, and for example the apple, I say I like the apple, I don't like the banana, I like the orange, I like the kiwi, I don't like grapes, okay, for example. Well, in this case, we would want to look for an element here. Imagine we want to look for the element banana into my structure. What I have to do is using lookup this way, banana. I want to look for it into my fruits array in all the elements, but matching with this field. Okay, so this way lookup is looking for the element banana into this this array, in all the array that is indicated by this star, and matching banana with the field name. Okay, well, in the same way as before, we can do something like this, and for example, oops, like it. If I like it, then I'm going to write and I like it. Else, for example, we can write here and I don't like it, for example. Okay, so let me now compile it and see how it works. Put it here, okay, and let me run it. Oops, here, run action, call program, and then this is what I'm getting. The position is 2, okay, the second element of my array is a banana, and I say I don't like it because banana, this field is off. Okay, so this is working fine. Well, so for looking for an element inside an array of data structures, we must use lookup this way, using the star as a wildcard. That means in this case, look for the element banana into the whole array, but matching with the field name. Okay. Well, let's make it a little more complex. Let me copy a different structure. Let me remove this. And this is what I'm going to do now. Let me copy this. Okay. Well, as you can see now, here we have a different data structure, an array of data structure with all these fields: name, surname. This is a field that is putting together the name and the surname. As you see, this is declared with the same position, in the same position as name. So this is putting together both fields. Okay, and we get a salary too. Okay, and we have initialized this structure with these 4 names. Well, in this case, we need to find an element in the array, but using 2 fields. Okay, so there are 2 fields together in the array, as you can see, and we have made an auxiliary field to put them together. And this way, we can find it using lookup. Okay, see this. This is what I'm going to do. We can declare these fields, and now we can do something like this. Name that I want to look for is Carl. The surname is Louis. Okay, so as I have initialized these 2 fields as Carl and Louis, then inside name, surname, we must put them together. Name, surname is equal to name plus surname. So they are together, but with 10 positions, both of them. Okay, if not, we cannot find the name and surname into my structure. Okay, then this way we can do this lookup name surname into where employees star dot name surname. Okay, and then we can write something like this: position is plus, and we can write, for example, and his salary is, for example, employees index dot salary. Okay, so if we run this program, compile it, and now we can run it, run action, call program, and we are getting this information. We're getting the position is 4. Okay, Carl Lewis is the 4th element in my array, and his salary is this this amount, so it is correct. Well, a few months ago I submitted an idea to IBM to try to improve these searches when using more than one field, but I'm still waiting for them to implement it. I think it could be very useful, because in that way we don't need to use all these auxiliary fields to do it. Okay, well, okay, so in this video we've been talking about a lookup built-in function in RPG, and we explored how it can help us find values inside arrays in different ways. It's really a useful tool, especially when working with sequential arrays or when we want more flexibility in our searches. I hope you liked the video and that it was useful to you. As always, remember to like and subscribe if you aren't already. See you on the next video, and thanks for watching.